This is Gamora Zen-Waberi Ben Titan, more commonly known by fans as Gamora, or simply the Green Lady from the insanely popular Marvel series Guardians of the Galaxy. Now, although the picture we just showed makes her seem very tranquil, Gamora stands there as the adopted daughter of the evil villain Thanos, and as the last surviving member of her formidable species, which makes Gamora arguably one of the most powerful women in the galaxy. Her power is fueled by her accelerated healing factor, superhuman strength, cat-like agility, enhanced speed, and she's a master martial artist. Now that you've hopefully been somewhat acquainted with Gamora, let's take a more in-depth look into the science behind her extraordinary abilities. Earlier we mentioned Gamora's abilities regarding her accelerated healing factors, but what exactly does that mean? Well, it means Gamora has the power to heal herself at a faster rate than most people. Her training as well as her body's cybernetic enhancement allowed Gamora to develop the ability to accelerate her own healing. Within all the enhancements she went through under Thanos, there is one basic thing that is partly the explanation for her ability, and that's her blood. In David Matchey's article, The Scientific and Ethical Dimensions of Striving for Perfection, he avails a scientific theory about how synthetic blood can be specifically designed to clot faster in order to prevent blood loss. In Gamora's case, it's not due to her blood being synthetic, but rather the results of the modifications to her body which ultimately caused this young girl's blood to clot much faster and enable the average injury to become a rare occurrence in her life. To fully understand Gamora's blood, we have to first look at the intricacies behind blood clotting. Blood clotting, also known as blood coagulation, is the process by which blood vessels repair ruptures after injury. It also serves as a necessary process that obstructs the body from losing too much blood. When a person has been injured, the blood platelets in the bloodstream, known as thrombocytes, begin to attach to the damaged area of the blood vessel and clump together to reduce bleeding. This initiates the clotting mechanism, which involves a multi-step cascade of enzymes, and these enzymes are meant to activate the next enzyme in the cascade. In this way, the effect of the initial damaged blood vessel can be quickly magnified, as a single enzyme at the first stage activates many copies of another enzyme at the next stage, each of which activates many more, continuing a cycle, and eventually works together to fix the clump at the wound. A coagulation cascade begins from 30 seconds to several minutes after injury for a human, but for Gamora, the process begins very quickly after the injury to her body. Once the clot forms, contraction of the platelets pulls the edges of the wound closer together, and fresh endothelial cells then grow across it. These endothelial cells provides a barrier between the blood and the rest of the body tissues. With fresh endothelial cells developing across her wounds at a rapid moment, Gamora's damaged blood vessels repair at an incredible speed. All of this ultimately allows Gamora to regenerate faster from what would normally be considered fatal wounds in a matter of moments.
Gamora's alien physiology and surgical modifications from Thanos give her superhuman strength and agility, as she is able to lift others with ease and leap at incredible heights. Gamora's numerous enhancements give her augmented durability and stamina, making her an extremely skilled fighter. Gamora's superhuman speed and ability can be attributed to her high percentage of fast-twitch muscle fibers. Everyone is born with multiple types of muscle fibers. Type 1, also known as slow twitch, Type 2A, which is intermediate fast twitch, and Type 2X, super fast twitch. The fast twitch muscles are capable of more power and velocity, and are used in powerful bursts of movements, like sprinting, which Gamora excels at. Her body is also specifically adapted to withstand the physiological debilitating effects of moving and running at high rates of speed without sustaining injury. With Gamora's high-intensity physical workouts, her enhanced respiratory system plays a major part in her success. The lungs bring oxygen to the body, which provides the body energy and eliminates carbon dioxide. The heart pumps oxygen into the muscles that are working during the exercise. Exercising regularly improves endurance, as it takes a longer and more intense activity to get to the point where we feel out of breath.
Gamora was enhanced with a cybernetic skeleton. Let's take a look at the computer science within it. So first off, computer science is the study of the theory of methods of processing information or data in computer systems. Cybernetic enhancements would be one or more pieces of one's autonomy that is substituted with a mechanical replacement. Computer science and the field of cybernetics often intermix, as computer science is included as one of the component parts of cybernetics. So for any of these enhancements to function, computer science will come into play. We can see here as the communication can seem to flow both ways within the enhancement. Like, it will have a scanner that will scan an input, and if conditions are met or unmet, it will spit out a certain output. We can see this in the diagram below. So, for example of Gamora's enhancement, the brain would send an input and tell her spine to move or act in a certain way. And if the enhancement would receive an input from their environment, such as pressure, the enhancement would then see if the certain conditions on the amount of pressure is true or false, and then it would spit out an output accordingly, and her spine would react. As a result, Gamora's cybernetic enhancement is definitely possible with the computer science and technology available. Cybernetic skeletons might not be too far off in the future, as in 2009, a leg prosthetic translated brain signals into physical movement. We can see how this will easily progress to be bigger and better in the future.
In the video, at around 12 seconds in, Gamora demonstrates her immense strength by breaking through Groot's thick tree roots and throwing Rocky Raccoon across an entire city plaza. Gamora's strength was built up with the aid of an enhanced body and lots of strength training. Through training, Gamora developed muscles that increased her strength tremendously. Let's take a deeper look into the chemistry behind her strength and muscle development. Firstly, Gamora's muscles were heavily strained and went through lots of metabolic stress during her training. Her intense training caused microscopic rips to form in her muscles, burning her stored energy, which was in the form of glucose, which is C6H12O6, releasing pyruvic acid, C3H4O3, which is pyruvate on the diagram, and ATP, energy molecules used by cells. This process is also known as a muscle aspect of the Cori cycle, which shows the process of glycolysis. The Cori cycle diagram shows how the process of glycolysis turns the glucose into 2-ATP and 2-pyruvate. Glycolysis describes the biochemical series of reactions in which cells break down glucose and use an enzyme catalyst, NAD, and ADP to form pyruvic acid, ATP, and NADH+, which is a transport molecule essential for metabolism during cellular respiration. The formula for glycolysis is as following: 1 glucose plus 2 NAD+, which is a catalyst enzyme, plus 2 ADP, which is uncharged ATP without energy, reacts to form 2 pyruvic acid, 2 ATP, 2 NADH+, and 2 hydrogen. After this process of glycolysis, the Cori cycle shows how anaerobic respiration takes place to turn the pyruvic acid into lactic acid. This process can be summarized as the following. Pyruvate and NADH reacts with lactate dehydrogenase, an enzyme required for metabolic energy production, to form lactic acid and NAD+, which is essentially oxidized NADH. Thus, lactic acid is released. When this lactic acid is released, an anabolic cascade is triggered. Lactic acid acted as a signal molecule in Gamora's body to tell it to start repairing the damaged muscles during her REM sleep cycle. Therefore, these biochemical processes resulted in the constant breakdown and stronger regeneration of Gamora's muscles, making her physically strong enough to take down her foes.
And now let's talk about the physics of Gamora. Does science back up how her death appears in Endgame? We can find the velocity her body was plummeting at using kinematic equation, specifically acceleration, since she would accelerate as she free falls. We're assuming Vormir has the same gravitational pull as Earth because not only is it a made-up location, but it's also not specified in media. Also, the character Vivians shown in the movie are not different from Vivians under Earth's gravitational pull. Here are some simple kinematic equations. V is velocity, delta x, or simply s, is displacement, a is representative of acceleration, t is time, and initial velocity is represented by VO. We'll also need the use of some force equations. In a freefall, the mass and the shape of the object does not affect the motion. However, her mass and shape will affect the force acting upon her body at impact. Gamora currently is 6 feet and 170 pounds. The following information. Air density of Earth is 1.225 kilograms per meters cubed. 1g force is equivalent to 9.80665 newtons of force per kilogram of mass. The drag coefficient of a skier is 1.0, and we're assuming that Gamora will have the same as she falls. Since the area of Gamora, who is 6 feet, would be around 1.6 meters squared, after finding out Gamora's body takes 756.35 newtons of force during the fall, the scene where they shot the body at the bottom cliff is far from accurate. Beyond all the science of Gamora, she remains one of the most popular figures in Marvel cinematic history, and she'll remain being a popular and inspirational hero for the rest of the generations to come.